Every question we have ever asked, where did we come from? What are we made of? What are the fundamental rules of reality? All of it leads back to one single explosive moment, a fraction of a second after the Big Bang. What if I told you that buried 100 meters beneath the peaceful countryside of Switzerland and France, humanity has built a time machine? Not a machine that travels through years, but one that travels back to the very first fiery moments of creation itself. The main topic of this video is not just physics, it's the art of cosmic recreation. This is the story of one of the most complex machines ever built by humankind, designed for one single audacious purpose: to accelerate particles almost at the speed of light, smash them together with unimaginable force. How does this machine work? What secrets has it already unlocked? And what does smashing a tiny proton have to do with understanding the origin of everything? Get ready to go inside the world's most powerful accelerator. To understand the LHC, you need to understand its guiding principle. It's not just a machine, it's a factory that runs on the single most famous equation in history, Einstein's E=mc². We all know the equation, but what does it mean? It means energy and matter are two sides of the same coin. They are interchangeable. The LHC takes particles, gives them an insane amount of energy of motion, the E, and when they collide, that energy is converted back into matter, the M. It's literally creating new particles out of pure energy. Particles so massive they only existed in the primordial soup of the early universe. We're not just observing the past, we're remaking it. So how do you give particles that much energy? You build a racetrack. The LHC is a circular accelerator, a 27-kilometer ring. Protons fly around this track millions of times, and on each lap, they get a powerful kick of energy from devices called radio frequency cavities. This is far more efficient than a linear accelerator, a straight line, where you only get one shot to accelerate the particle. To get to LHC energies in a straight line, you'd need an accelerator so long it would stretch from Lisbon to Moscow. The scale here is almost impossible to comprehend. Let's try. The final energy of the collisions is 13 Tera-electronvolts, or TeV. The article gives a brilliant analogy for this. In everyday terms, that's roughly the energy of a safety pin dropped, from just 2 centimeters. So what's the big deal? The magic is that CERN concentrates that tiny, everyday energy into a space 1 trillion times smaller than a mosquito. It's this impossible concentration of energy that mimics the conditions right after the Big Bang. And they don't just do one collision, they do billions. A key performance indicator is luminosity, or the number of potential collisions. At its peak, the LHC can generate 1 billion proton-proton collisions every single second. It is a constant, raging firework display of creation. But the LHC doesn't work alone. A proton's journey from a simple gas bottle to near light speed is like an Olympic relay race, passing through a chain of smaller, older accelerators. It starts with a bottle of hydrogen gas. The atoms are stripped of their electrons, leaving just protons. Step 1, they get their first kick in a linear accelerator. Step 2, they're passed to the proton synchrotron booster. Step 3, then to the larger proton synchrotron, PS, a machine from the 1950s that is still the heart of CERN. Step 4, then to the even larger superproton synchrotron, SPS. Each machine boosts the energy, shapes the beam, and divides the protons into bunches, preparing them for the final leg of the race. Only after this incredible journey are they finally injected into the main event, the Large Hadron Collider, where they will race around for hours, guided by thousands of superconducting magnets colder than deep space before being steered into their final spectacular collision. A 27-kilometer ring, thousands of scientists, 1 billion collisions per second. But it all comes down to one question: why? Why do we do this? We've seen how humanity built a time machine to recreate the first moments of existence. We've explored how, by using Einstein's recipe, we can turn pure energy into matter, discovering fundamental particles like the Higgs Boson, which gives mass to everything in the universe. This quest to understand the infinitely small is one of the most profound and hopeful things we do. In a world so often divided, Projects like CERN unite thousands of scientists from over 100 nations, all working together to answer the shared questions of our origin. The technological ambition here pushes humanity forward, giving us practical inventions from medical imaging like PET scans to the World Wide Web itself, which was born at CERN. By smashing particles, we aren't destroying, we are revealing. We're uncovering the beautiful, intricate, and deeply ordered set of rules that govern our reality. We are learning our own origin story, and in that shared quest, we find the very best of what it means to be human, endlessly curious, brilliantly collaborative, and always reaching for the next frontier. If this interesting subject touched you, consider leaving a like and subscribing to the channel. We are not alone. We are all part of a much larger whole. Thanks for watching, and I see you next time.